Hey guys, it's Ben here, and today I'm going to be walking through the Willow TryHackMe challenge. This is a medium rated challenge and it's a Linux box, and I thought this was quite a fun one, so I would like to share my solution. So I've got the box up and running, I've got a directory to put my work in, I'm going to get a terminal set up, and like I always do, I'm going to make directories recon and exploits. I'm just going to cd into recon, I'm going to make directories nmap, so I can put my nmap scans in there, and I'm going to start off with a quick nmap scan covering all the ports. So T4, and we'll output this to fast tcp.txt. So this challenge, just to give you some context, this involves a bit of cryptography. There's some steganography here, and there's also some Linux privilege escalation. So that nmap scan covering all the ports has been returned. We can see there are 4 supposed services. We don't know what these services actually are until we do a full scan or investigate them further. So I will do that right now. I'm going to specify the ports just to be 22, which is supposedly SSH, HTTP, RPC bind on port 111 and 2049 NFS, network file share. I'm going to do service, default scripts, operating system enumeration, and I'm going to output this to thorough tcp.txt. I need to be sudo for that, so I'm going to run that as sudo. We have noticed there is a supposed web server running on port 80, so we can investigate that. Let's see what this web page is, and we've got a lot of text, right? Looking at the top of this sort of looks like hexadecimal, so perhaps this is hex, and then it goes to all numbers down here, so there's no letters, but at the beginning there's some letters here. So let's just copy and paste this into CyberChef, so we can actually see for sure what is on this recovery page. Pop this in here from hex. Hey Willow, here's your SSH private key. You will know where the decryption key is. So it looks like we've got an SSH private key, but it looks like the private key just consists of these numbers. We don't really know what they are yet, but let's just copy this and let's write a vi or suball notes actually, suball notes.txt. I'm going to close this and we'll paste the notes in here. So we've got this SSH private key, and you know what the decryption key is. This does sort of look, if you look at the individual numbers, it starts off with 5 instances of this 2367 string, and then it goes to 907 again, and then we do see some more 2357, another 5, and if you look at the end, there's another lot of 2357s, and there is another 5 here. So perhaps these are representing the individual characters. If you look, I believe we can do it in here actually. If we look, let me just clear this output, and let's generate an RSA key. The RSA private keys begin with 5 lots of this dash, and then it says begin RSA private key, and then after this string there's another 5 lots. So maybe this SSH private key is encrypted, and instead of the key as a whole being encrypted, each individual character is encrypted individually. It says we know where the decryption key is, but I don't know where the decryption key is, but we've got other stuff to discover. So let's do some more looking around and see if we can find where this decryption key is. We've got a network file share, so let's see if we can actually mount that. Right, I'm going to go back out into recon and make directory network file share. Is there an NFS ls? Is that a command? There's something like list shares NFS. I'm trying to remember the command to do this because I don't remember, unfortunately. But is it show mount? Or is that only if they're mounted? I want to find the command because we know there's an NFS share. Maybe we can view some of the files. Maybe it's show mount. Maybe I'm getting confused. And we'll put the IP address in there, so we'll see, does this reveal any shares we can mount? And there's this /var failsafe share, so we could possibly mount this into our NFS share and then view the contents of this. Let's do this. Let's see, mount NFS share. Let's see how we do this because I cannot remember exactly. Yeah, something like this will work, right? So let's just copy this. We'll put the IP address here, so mount this share here, and then I think we put the share we want to mount is var failsafe, and where we want to put this mount is on this NFS share. Is this going to work, or is it? Do I just do like this? And it loads, and it looks like if we go into NFS now, this did work. We've successfully sorry about that. We've successfully mounted the share, and there's this file called RSA keys. So let's just cat out this RSA keys and have a look. So public key pair and a private key pair. Okay. If we go back to this hex decoded message which was left on the web server, it says you know where your decryption key is. So perhaps these keys here will be used to decrypt this big mess. I'm not a master at RSA. We know it is encrypted with RSA, so we can choose, and I'm confident from the fact that we've found it sort of follows the pattern of each character is individually encrypted. What I can do is I can play around with this, and we say we know, look, this is going to decrypt to the character, which is a dash. So we can play around and figure out how these public keys and private keys work together to actually decrypt. So what I can do is RSA decryptor, and there's a website I used, and I will spot it. It's this one here. So you put the value of the ciphertext message, which it looks like it saved my output from before, which is 2367. That's what's encrypted. The public key is usually this, and it was already set to that, so I just left it at that. Well, there's a private key, and there's a public key here. We've got two ones, so perhaps the public key is going to be this. When I did this originally, it was a bit of hit and miss, but I eventually put the public key here and put a private key value here, and if we do this, we can see it does decrypt to this dash sign. So we can have some more confirmation. We know it's going to begin. If we go back to this cyberchef, after this last dash, it's going to start with a B. So just to make sure, let's have a look if this is a B, right? Let's see, is this a B? If we put this in the ciphertext, and it is a B. So we know how to decrypt this. Obviously, we've got a lot of characters here to decrypt. I really would not like to do this manually, do one by one. That would take a long time. I want to automate this with Python, so I'm going to write a Python script which does this for me. However, we don't really know what this is doing. We just plug it in and it's doing it. So first of all, I need to figure out how is RSA really working. So RSA explained. Let's try see if we can find an article for this. This brilliant article was quite good. Yeah. So it starts off saying how it's encrypted. There's a lot of maths, some modular arithmetic. I don't want to go into that. This line here, the receiver computes C to the D, and that's equal to M mod N. So our original number, or our plain text, is M, C is our ciphertext, and D, if you go back to here, D is the private key value. N is the public key value. So we can probably, recreate this in Python, because we know what it's doing. So can we do this in Python? Enough talking, let's actually get on with this. I'm going to put this in my exploits directory, and I'm going to call this RSA decoder.py. Just to start, we know C is our ciphertext. Let's just do this character by character. To start, we know it is going to be 2367. Let's see if we can recreate this, and then if this works, we could do a whole array of it. I'm just going to do it as an integer like that, not a string. We know, if we go back to here, our N value is this. I'm going to copy and paste this. We know our N value is this. We know our private key, which is D, is this. So D is this. If we go to this website here, RSA encryption, we can see it does C to the D modulo N, and M is our value. So we could say, let's just print this, print C to the power of D, which is going to be this, C to the power of D, it's going to be quite a big number, modulo N, so the remainder when divided by N is this percent sign, and that's this. So this should give us an integer. This won't give us like a character, but we can convert that. Let's just check this works. So cd into exploits, have I written that? And we can do Python RSA decoder. So that gives 45. What we can do is we can find the actual character of this integer, the char code of 45, and look, it's that dash, what we expected. So that's good, right? We can individually decode a single character. What I'm now going to do is get the string. I'm going to format it so it has commas in between each space, and I'm going to paste this into our Python array and iterate through each one individually. So what I'm going to do is I'm going to go find and replace, just so we could probably do this in the Linux terminal, but I'm lazy. I'm going to space and replace that with commas. So now we've got a string of the individual encrypted characters represented as the encrypted char code characters, and we can paste this into here. Let's see if this works. So it should start in 2367. That does work, and this is getting a. I'm going to put this here. This is getting a bit awkward. Sorry about this. I'm going to actually open this in Sublime Text because I'll be able to see it a bit better. So Subl RSA decoder. So I'm going to word wrap this just to make sure we can see it. It's got a nice ending. Yep, it starts in 2367 and it ends in it. Instead of printing each one individually, I'm going to make a string, which I'm going to build up the string by looping through it, and I'm going to say for I in C. So I'm going to loop through each of the integers in this string, and I'm going to say, what do I want to do? I want to add to the string the char, the character representing C to the power of D modulo N. So I believe this is what I did. And then at the end of it, we can print string, and hopefully this will go through each of these numbers one by one, raise it to the power of 61527, modulo that mod N, and that will give you the char code for the character in that position. We will then convert that char code to an actual character, add that to the string, and we'll slowly build up the string. Let's see if this works. So now if we run Python RSA decoder, we've got an issue. And what I've done here is I should replace this with I instead of C, because every time it references that, it's referencing the whole array. I need to reference each individual character. So let's run this, and it is taking some time because there's a lot of computation which is needed for this, but if it does eventually output, we'll see what we find. It is taking its time, but look, we've got the RSA private key. It's finally decrypted each character by character, whacked it all together, and we've got this RSA private key. I thought this was a really neat way to get it. So let's put this in our exploits. You would notice this is encrypted, so we may have to do some hash cracking and turn it into a thing. But yeah, enough talking. Let's actually ID RSA. Let's paste this in here. There we go. I believe we'll need to change the permissions on this, as we won't be able to use it. If we look at this original message, it says notes. It said, "Hey Willow," so perhaps that's the username. So Willow. Let's do tag by ID RSA. We know it's going to be Willow, and the IP address is this. So we can copy this IP address, like so. And let's run this. Yes. And it asks for the passphrase for the key. I don't know this passphrase. However, we can find it out. We can basically turn this RSA SSH key into a hash and then crack the hash to find the passphrase. A good way to do this is SSH to John or SSH to John. I didn't do it right. And then we supply the key there, and I'm going to say hashed SSH key. We've got this hashed SSH key, so we can just cat that out. What I am going to do is put this into John the Ripper, hashed SSH key. The format is going to be SSH, and the word list I'm going to supply is going to be user share word lists rockq. And it's already cracked it because I've done it previously. If I do show, how do I actually? Can I just do like this? This is how you would crack it. I believe if I go like this, it will show me it shows me what the password would be, and this is Wildflower. So this is the password which is used to encrypt the RSA SSH key. So I'm going to paste this down here. This is useful to know, Wildflower. Now if we go back and try SSH on again and paste in Wildflower here, it says no mutual signature supported. So perhaps we weren't able to agree on a cipher suite, or perhaps my client's not accepting theirs for some reason. If I search this up, I found a little way you can bypass this. If this loads. I think this is caused because the key we use, or the key the server uses, is maybe deprecated, and the SSH client doesn't like that and it wants a secure one. But we can force it to use our SSH RSA algorithm by doing this, and we'll set an equals here, and the password is Wildflower, and we're in. Right, we're in. We're in, and we've got this user.jpg. So I want to send this across to my my box. I could probably use SCP secure copy. I'm going to be a bit of a cheaty way and just base64 encoding it, and then just copy this across. I know it's not good, but it works, right? That's all we need to do. I'll just copy the base64 encoded. What I'll do is I'm going to make vi base64 encoded. I'm going to paste this in here, and I'm going to right click this. I'm now going to cat this base64 encoded. I'm going to pipe it into base64 decoded, and then I'm going to output this to user.jpg. Decode, sorry. If we actually open this file up now, let's go to the TryHackMe directory, and desktop actually, sorry, TryHackMe, and we'll go to Willow, which is going to be down here, Willow walkthrough. In our exploits, we've got this user.txt, and the flag is there, weeping beneath the willow tree. So we've got the first flag, nice. Yeah, we need to get a root now. So let's see what capabilities we have. First of all, I always like to, instead of whacking in limpies and going through that massive output, I want to see if do we have any quick, easy wins. So you can check for any SUID binaries, right? Type F perm tac U equals S. Is there any SUID binaries we can use? That's the first thing I would do. I'm not going to bother going through all of these and checking them. There may be an easier win with these SUID binaries. I instead looked if we have any sudo capabilities as this Willow user. So I did sudo tacl, and it says, look, I can use this command here, bin mount, so we can use the mount command in the dev directory, and then all of these parameters after this is up to my choice. But basically, I can mount a folder or a file from the dev directory. So let's just look in this dev directory, cd and dev. Let's clear this out and let's go ls tacl. There's quite a lot of files down here. The files which are like the block devices. Well, there's a few ways you can do this, right? Let's do some how to show unmounted partitions. There's this lsblk file which will do it. lsblk. Okay, permission denied. Okay, that's a bit annoying, right? But all these unmounted files, they'll have this B to show they're a block device. They'll also have this, they'd be in the disk group. So there's a few ways you could probably do this. You could say like find dev type B, and that would return all the block devices. And we can see there's these ones, and there's this hidden backup in this dev folder. This stands out, right? This must be something we have to do. So yeah, let's try this. Let's first of all let's cd into home Willow, and let's make directory finding. What I'm going to do, because we've got this sudo capability, I can run sudo bin mount, and the directory or the file we want to mount, the block device we want to mount, is this hidden backup. What do I want to mount it to? I want to mount it to home Willow. What did I call it? Finding. We've now got this finding folder here. Let's cd into finding, and we can see it's mounted this creds.txt. So let's cat out creds.txt, and we've got, it looks like credentials to the user, the root account and the Willow account. So what we can do is we can paste this in here. We've got these two sets of credentials. Let's see if we can do an easy privilege. An easy privilege escalate to root. Sudo root, put in the password. I'm now root. Nice, let's go to the root and let's grab the root flag. Cat root.txt. But oh look, this would be too easy, don't you think? I actually gave you the root flag some time ago. You've got my password now. Go find your flag. So that's a bit interesting, right? You've got the password. Go find the flag. And they've given us the root flag some time ago. This is where I got stuck on, and I spent ages, like at least over an hour, looking around the box trying to find another flag for root. I didn't. In the end, I ended up going back to this user flag here, right? This user.jpg. This isn't like your typical flag being a user.txt, it's a JPEG. So Perhaps there's some steganography which includes this password here, the root password, because it says I gave you the root flag some time ago, so that eventually I figured out that is the case. We can use the steghide command. I believe there's an info on this user.jpg. Get information about embedded data. We enter the passphrase, which is this. Let's just check if this is the case, right? And there's this root.txt flag embedded within the user.jpg. So let's just extract this. Let's get a nice extract, and then I believe it's xf, or is it xf like this? Let's see, because I cannot remember the. Is it like this? xf. The passphrase is this, and we've extracted the root flag like that. So we've got the user flag, we've got the root flag, and we're all done. So I hope you've enjoyed this challenge, and I'll see you on the next one.